Hello, my name is Ege. I'm a second-year computer science student at Bilkent University. Today, I'm going to present you my lab project about measuring rotational kinetic energy on inclined plane. The purpose of this experiment is to find rotational kinetic energy using rolling motion and energy conservation. In this experiment, the time for the displacements and the displacements and the time taken will be measured. Background information. Knowing the displacement and time, we can calculate the average speed, which will help us calculate the tangential speed of the rolling cylinder. Knowing the tangential speed, we can calculate the angular speed, and knowing the angular speed, we can calculate the kinetic rotational energy of the cylinder throughout its movements. By the conservation of mechanical energy, we also get an energy value, and it will eventually give us the error percentage of this experiment. Here you can see the setup of my experiments and my equipments. I use an inclined plane with 5 data points, 16 centimeters between each data point and the overall length of 80 centimeters, a cylinder, a camera or stopwatch to measure the time, a vernier caliper, and a ruler. Here you can see the demonstration of my experiment. I have released the cylinder from top of the plane and I have measured the time taken from each data point. I measured the data points by looking at the camera footage of this experiment. And I have repeated this experiment 5 times in order to reduce the measurement errors. On the left, you can see the table of my initial known values for this experiment, the distance, angle, height of my inclined plane, and radius, mass, and moment of inertia of my cylinder. From doing this experiment, I have gathered these data. The first table gives me the time it took to travel different displacements, and the second one gives the angular speed of cylinder for these displacements. Using these two data, I have calculated the energy types for each data point. You can see the potential energy, kinetic translational energy, and kinetic rotational energy of the cylinder throughout its movement. And on the right, you can see a graphic for the energy related to time. The results of this experiment can be shown clearly here. The initial energy of this experiment, the translational energy, and the final translational energy and final rotational energy of the experiment. Using these logics, we have calculated the percentage accuracy of the experiment and error percentage of my experiment. The strength of my experiment is that I have used a low angle and a high coefficient for my cylinder, which resulted in a better measurement for my experiment. I have also measured the data from camera, which is more precise, and I have also repeated the experiment 5 times, which gave me more accurate results. The weak part of my experiment is that air resistance and work of friction has resulted in loss of some energy, and that's why my error percentage is a bit high. And also the experiment was conducted by one person, which means I may have made some personal errors in my experiment as well.